And we've got this fairly meaty decay question to finish today. Alright, so we know it's going to be electron capture, so we know that one. So there's our electron capture interaction. Or I could have put proton plus electron going to neutron plus neutrino there. So I've got a proton turning into a neutron, so the number of protons is going to go down one, but the number of nucleons is going to stay the same. And then by charge conservation, I need a 0 there. By baryon conservation, I need a 0 there. And then by lepton conservation, that's a lepton. So this also needs to be a lepton. So it's the neutrino, not the antineutrino. Then we're sort of making a nice connection to quantum here. So remember that there's our energy of the photon. 1 electron volt is 1.6 times 10 to the minus 19 joules. So that is going to be the energy of our photon in joules for the first mark. For the second mark, rearranging the formula, and third mark, putting all the numbers in and getting the accurate answer there. Remember, you always need to show your working. I'm leaving it out because I've cut out all the space. Okay, and so then the last bit here, we've got a different decay now. And so here it is. So we're told that the potassium nucleus is going to decay into a calcium nucleus, and then by conservation of charge, we can see that we need a -1. So this first particle here, 19 is 20 minus 1. And then by baryon conservation, 40 is equal to 40 plus 0. But then we've got to do lepton conservation. No leptons is equal to no leptons plus 1 lepton. And so then we have to have a -1. So we need to have an anti-lepton there. But that's got to have 0 and 0 because we've already done all the other conservation rules, and that means that it's the anti-neutrino. Okay, so just how the emissions from a nucleus of decaying potassium can be used to confirm which one's happening. So is it that one or is it this one? Well, the neutrinos, as we know, are incredibly difficult to detect. So basically, if you've got this reaction, you're not going to detect your neutrinos. So you're not going to detect anything coming off if it's this interaction, you'll end up with argon and nothing coming off. But if it's this one, you're going to have a beta particle coming out. And so that's what you say for here. And you could detect a beta particle with a Geiger-Muller counter, something like that. And there you go, that's that for 3 marks.